Hello everybody, Bobby back here from Full Tilt Weather again. Been a while since I've done one of these. Close to a month and a half or 2 months now. Actually doing a video. Uh, but here we are. We're going to be talking about the severe weather threat that is likely to occur midweek over portions of East Texas through Dixie Alley. Primary area of threat right now, a lot of the models are not picking up the probability of formation so well. I think that's because of the lower Cape, but trending through the event we've seen through northeast Oklahoma into Missouri, that's not a good sign, really. So we have a little bit more Cape with this event to work with than we did the last event through Oklahoma and Missouri. Go ahead and draw a box to a certain area here we're more than anything worried about. This is going to be our primary area of worry right now. That actually is a little too low, probably more arcing between Alexandria here and Austin. Go ahead and draw that line back. Right in this area is going to be our primary area of threat right now. Best tornado threat is going to be from right along this line. That's going to be the best tornado threat right through here. If I even wanted to lower it to where the best chance is, it includes Dallas currently. This is the very best. This is a 14 to 21% tornado threat right now, equivalently. This is about a 7 to 14% chance. The rest of this area currently outlooked through here would be about a 2 to 7% chance. Some tornadoes definitely do look likely right now. As you can see, this is the outrun for the standard NAMAS. We switch over to the NAMAS 3. You're going to see all this stuff is really expected to be clustered. So, if we get this formation, you may not be able to see cells go up high enough to be tornadic. This is a very likely output. But in that jet, if one of them goes up, you're going to be dealing with a wind threat. You're going to be dealing with a possible tornado threat. Just because a tornado threat is possible doesn't mean that, there's definitely going to be a tornado. Here's our base numbers here. We're going to go through some of them just to kind of explain to y'all what we're kind of looking at. We'll go through SIGNIF, TOR. They're going to be a lot of high percentage. As you can see, the model agrees with what I told you. Let's take a pull here from the middle of this. And we'll go through the numbers real quick. Always takes forever to take a pull. Here we go. First of all, first thing I see, level of free convection is separated from the base. I have a 75-degree turn here. There's a little bit of inhibition. Looks like a little bit too much within the base 1,000-foot sector right here because you have a little inflow here. This could create a smaller cap to the lower part of the storm as it evolves through the dry and wet aerobatic. Cape's not beautiful. We're not even over 1,985 base Cape. Showing some possibility of severe hail. Not really great. D-Cape's pretty strong. Nice inflow. This is one thing you really want to, as a meteorologist, be very understanding of. Storm motion vector. So, what we're dealing with right here is a 53 southwest wind. So this is a 53 knot southwest wind. That's going to equate to about a 56 mile per hour wind. A lot of times I don't always equate that back into a formula, but it's a little bit stronger. Southwestern wind creates rotation, and as you can tell, we have some lifted air occurring here. This is your hail trigon right here, allowing for some hail inflow. Got a stronger circulation. With the hodograph being circular like this, we're leading to, tornado possible. Hazmat says tornado, possible EF3 at low chance. That's bullshit. Don't ever trust hazmat. Hazmat is useless. Government's program of wasted money. That's all hazmat is. SCARS analog, same thing. Garbage. Learn the numbers. That's the way meteorology needs to be done, and the way meteorology always will be done. No computer can equate all this together into a formula, because every scenario is different. Like, let me explain something. 989K, if this was out West Texas in May, I would laugh. Let me explain why. Because you're going to be dealing with a warm front base out west. That warm front base, 985K, might not be enough to bring something up to bring a sprinkle over the panhandle. You're going to need, 1,800 to... you could get as high as 9,000. It could happen. That's extremely rare, but usually you're going to be working with something between, let's say, 16,000 and 4,000. These are base parameters. You're dealing with 16,000, you're dealing with separated clustered cells. You're dealing with 21,000, you're dealing with definite separated cells or some form of separated linear cell. You get to that 3,000 mark, anything over that anywhere in the United States is linear. That's whenever you have your big wind lines, last year, the start of the year, we had that huge line over northeast Texas that produced 57 tornadoes in like 40 hours and a little over 3,000 severe warnings, producing winds up to 109 mile per hour over Jefferson, Texas. That would be a great theory of what a actual QCLS linear baseline is. This is not that. This is a clustered cell that's going to be really tore apart. Some people could see some tornadoes. Some people could see some very isolated hail. Definitely going to be a wind threat involved. The tornado possibility here is pretty high, but given the lower Cape, the tornado damage output expected is pretty low, because you're not going to get a lot of really ear back kicking storms in 985K. Not going to happen. Will there be a tornado watch? It's likely. It's likely. That's what I'm going to go with there. I think we probably will see a watch activated. The better odds, of course, for one on the ground is going to be right here around Dallas. Over into the Davison Mountain Range. Whenever it meets this Davison Mountain Range, I don't really care what the model says. It's not going to be all this floaty through this mountain range. Because what's going to happen here is it's going to have to die and crawl. Whenever it climbs and gets to the top of the mountain range, it'll shoot back down. And that may lead to a big topography output here along this area. Because you got to think, right along here we have the Davison Mountain Range. And this is the other portion of the Ozarks. Right through here. So, this is why, this is base meteorology or topography. If you look at this, I'm going to explain something here. Okay, so we have the Davison here. This is the other part of the mountain range, goes through Arkansas. Man, what's the name of it? I just said it a minute ago. I lost my mind. Sorry. Thinking about too many things, sometimes you just forget. So anything that moves across this area, which come from the Rockies, way up here usually, climbs along this area and usually weakens, but it can produce shear southwardly. That's the reason you see areas like Sherman, Greenville, Dallas, all the way even into Ennis, Cleburne, all this begin to get a lot of tornado output. This is just a base thing. Go ahead and draw this mountain range back. We're just going to include all of it. But whenever stuff moves along this line, you're going to see it move. It begins to meet that larger part of elevation here. Well, whenever the line's moving, so let's say this is a partial bowing line going from Denton to McAllister. We're just making like a little partial linear line. This is something you would see if you've covered weather over Texas and Oklahoma for any amount of time. You have seen this scenario. So whenever the top side of it up here around Durant and Atoga all the way up into McAllister starts to climb, this line starts to have issues and breaks apart. Well, what's happening is there's air being pushed up and around. So whenever that air gets pushed around, you create a little southwestern. And that's what makes all this area down here, the Canton vein, the Paris vein, all of this blow up. It's just that simple mountain range right here, the Davison Mountains. And it all ties together, and that's something, coming into this weekend setup, really need to stay aware of, because that could change at any point, and you do have a topography advantage here. As most people know, we've seen a lot of tornadoes, directly here between I-20 and I-30. Very hopping area. I actually did a paper. Believe it or not, Marshall, Texas owns the record for the most severe warnings and most tornado warnings of anywhere in the United States. Anywhere in the United States. You'd be surprised where number 2 is. Dothan, Alabama. You'd be surprised. Well, if you live in Alabama, you wouldn't be surprised what number 3 is. I wasn't surprised. I was a little surprised about Dothan. I wasn't really surprised about the next one here. Man, I can't even find it. Coleman, Alabama. That's the name of the town. There it is. Coleman, Alabama. Okay. This little something if you want to learn something about weather. Let's explain why this happens. Very simple. They all three have the same environment. Mountain range. The bottom mountain range of Alabama. Right here. Moving into, around Americus, Georgia. Going up into Warner Robinson, which usually protects that area. I don't know if y'all remember 2015, the large tornado that hit Albany, Georgia. I was actually on that cell. It was kicking and raring. Was on the cell that 2 days before that produced a tornado in Hattiesburg, Mississippi too. Hattiesburg, Mississippi, in that area, I call it the Devil's Box. 20 and 10 connected to 55 and 56. That's a very active area. But you're seeing up here, you have air moving. So you have any cell moving through this area. We're just going to draw another linear line. Moving across. whenever this air begins to move along this line, well, if it can go below and there's a southwesterly approaching, it would have to approach from over here. And man, that is one bad arrow, bro. Air's going to get trapped below. So you begin to see little rotation spikes through this area. That makes Dothan PowerPoint. Because the end of that line heads to Dothan, Alabama. I've really gotten off into something I probably shouldn't have here. Sorry, guys. We'll go through Coleman here again for 1 second. Same thing, as you can see, it has the larger line of, this would be the Appalachians. Or would it? That is the Smokies, actually. This is the Appalachians. Yeah, this is the Smokies. Bottom part of the Smokies. So same thing, you have air forming over here, usually in a dry slot, right around south of Memphis. Line moves east, highly elevated, and you have all this area right here through Chattanooga that's sending all these very fast southwesterly winds. They're approaching Coleman, turning rotation right here, as you can see, right along this area through Warrior Colony all the way up, rotating them, and that's the perfect point where everything meets. Just due to topography. That's all it is. But I kind of want to explain that so y'all kind of understood a little bit more about topography. I know I use that word all the time, and most people don't understand it. I don't feel. Maybe you do understand it. I don't know. If you do, please tell me in the comments you understood it. If not, I guess I wasted. If you do, I guess I wasted 6 minutes, 7 minutes of your life. If you don't, well, if anybody says the word topography, now you have an understanding of what we're referring to whenever that's said. Let's go ahead and move into standard NamUs numbers. We're going to take a pull right here. This is going to be right about Joaquin area. Go ahead and take a pull out of this. 700. That may have been behind the line. Let's back it up one. Some kind of huge CIN expected there. Oh, I was behind the line. Okay. So the CIM was actually the possible severe weather. So yeah, here's the center pull. A couple things I notice here right away. The LFC is more down into the level free convection here we're having. Have a little bit of a cap, 14 cap. It's a little stronger headed up the line. Base cap, we have this little nipple here. This is what's referred to as a rain nipple, because this is a higher dew point. So this is definitely going to be a rain wrap cell. That's what that would indicate. The jet has slowed down some, have some stronger decape inflow. A little bit of a hail production. This cell's compensating for something in this run, and I don't exactly know what. Okay. Let's go back and look at this, what actually is happening here. Okay, so this is right along the same time. Maybe they're fighting. Maybe the model's seeing them fight. That's a possibility. Nudge it back a minute. Yep, okay. Yep, that's the problem. So that was such of a scenario pop here. What's happening is this model is currently thinking there could be a massively large cell that individualizes itself in front of the line, and could be a large hail threat and a tornado threat headed just north of Vicksburg, basically. It'd be right in between about Ruston and Vicksburg area. Vicksburg's about right here. Ruston's about right here. So right in between that area, primary population would wind up being West Monroe and Monroe. I don't know. This is a possibility. No other models are really thinking this. I'm going to say I disagree with it right away, but that's what the numbers are showing. So I can't lie to you. See, the reason I knew there was a fight here, you see this little inflow here? We're having real nice inhibition in multiple levels. Something has to be affecting the line for inhibition. That's just a straight given thing. But that's kind of what we're looking at right now. This wound up being more of a weather knowledge deal, I suppose, than a forecast in some ways. Half of it was a forecast, half of it's knowledge of weather. Sorry about that, and this got really, really long, so I don't know. But that's kind of our outlook for right now. Again, it's going to be a long night, Tuesday night, heading into Wednesday. I'll have all my computers up, and I'll be ready. I do live in the threat level for this, so, I'll be keeping a look out the back door, too. But, just another one of them nights, little cold front coming. Another thing I want to show y'all guys, and this has went extremely long. We have another possible threat headed towards the end of the month here. So this is going to probably wind up being another threat Saturday right here along this line. This is a new line, not the one we've been talking about. A new line expected Saturday, November 28th. And there is another super cold front line. This actually could be partially tropical, but another line expected here about the 4th. And anybody thinking this is going to be snow, I hate to let you down, probably not. Sorry, guys. I mean, it's not impossible. When we get a little closer, we'll talk more about it. But I'm not a fan of this output. Where are you going to get the temperature variations to that low? It's not going to happen. But that's kind of what we're looking at for future cast right now and stuff that have been keeping a close eye on. But I'm going to go ahead and get off here. And oh my God, this is a 22-minute video. I'm sorry. If anybody made it this far, you're a soldier, because I just ramble on like an idiot. But anyway, I'm gonna get off of here. Thank you all for the support to the channel, support to the page. It's immense. It really is. I get messages from people. I get people saying stuff. It's it literally in a lot of ways keeps me going. Some of these hours and some of the numbers you're going through and everything, it's not that easy at times, and you look back at April, time's been up hours and hours and days, not hours, days on end. Or, only slept 1 or 2 hours and got back up and, went back at it after I've been up 3 days. It's not as easy as people think. I'm not saying it's the hardest job in the world. I'm not a cop. I'm not in the armed forces. My heart goes out to them guys completely. Y'all guys are my heroes either way. But what I am saying is, it's not working for McDonald's. That's what I'm saying. But I'm going to go ahead and get off of here. Thank you all for the follows. Everything you do. Comments, likes, responses, messages. I love y'all. I'm going to go ahead and get off here.